Okay, we'll get started. Now we move on to the second part for the coursework too. So we covered all these backend, Node.js, Express, etc. So that's the first part. The second part is about and make your app progressive. So we're gonna have this term progressive web apps a lot, and in most cases I just say PWA because it's faster and shorter. Okay, so this is a kind of more abstract definition. We're going to explain a little bit more later on. So it's using modern web APIs, for example, something called a Serviceworker, and with the traditional progressive enhancement strategy. That just basically means if your browser or say the phone does not support Serviceworker, it still can work. And then to create cross-platform web applications. So that basically means these were not only working on the say desktop, either Windows or Mac, but also going to work on say iOS or Android as well. Okay, and one of the goals of the PWA is to give it similar user experience as native apps. So when we talk about native apps, these are the things you install from say Google Play or App Store. So we want to make it have a similar experience and as those apps. Okay, and so and one of the advantage of PWA or the progressive web apps and is they are discoverable in the sense you can Google it and when you find it, it give you a link and you just need to click on the link and you can start running it. You don't have to go to say Play Store and or Google Play, say App Store or Google Play to install them. And these are also work offline. So actually, even if you don't have internet connection, you should have some of the functions of the app. And finally, you can add an icon on your home screen, just as native app. Okay, and okay, so there is no like a strict rules to say what makes an app, say PWA, or it's more like a spectrum. You can have an app which is say 60% PWA, which is less than an app which is say 80% or 95% PWA. But at least it should have these properties and it should be able to work offline. When you don't have internet connection, it should work. And it should be able to install, in the sense you add an icon to your home screen, easy to synchronize, that's probably easy, and also can send push notifications. So this is quite natural in all these native apps. So if you have a new message, there will be a notification on your phone say you received a new message. And the PWA will do something similar as well. And so the way to measure how PWA app is, and there's lots of tools, and the most popular one is called Lighthouse. So this is built into the Chrome already, so it's part of a Chrome. It used to be extension, and then we're going to have a look at how that works, and a little later we'll come to some examples of PWAs. Okay. So these are the important things, and most of these we already covered, so I'm not going to repeat those. Okay, and some other advantages is because in the PWA, all the files are saved locally wherever it's possible, so make it very fast to load, and so it's even faster than so basically you're loading everything from your the phone or the computer locally, not from the internet. Makes it much faster. And the other thing is say, so every update is minimal in the sense you only need to change the file that's being updated. For example, if your website is 100 megabytes, but in the version 1.01, you change the one of the files. So only that file needs to be changed. The rest has to be remain. Don't have to be changed at all. And whereas it's say in native apps, for example, I don't know, Google WhatsApp or Google Map, And for each new version, even the change is tiny, 1 or 2 files, then the entire app has to be re-downloaded and reinstalled. So in that sense, and progress of apps will be better. Okay, and so now look at some examples, and which actually using PWA and has been quite successful. And so, anyone know Flipkart? Oh no. Okay, so the Flipkart is the equivalent of Amazon but in India. So that's like the biggest online e-commerce website in India. So there's some report says they changed the app into a progressive web app in 2015, and which results in 70% increase in conversions. The conversions means people visited the website, actually buy something in the end. And this is partly very important in the Indian setting because there the speed of the phone connecting to the internet is much slower than say in UK average. Some people are still on 3G or even 2G connections. Okay, to get it to work in those conditions, so for example, to minimize the amount of things you need to load or even work offline is very important. Okay, so this is another app called AliExpress. Anyone heard of that again? So AliExpress is actually available internationally, and that's like the international branch of something called Alibaba, which is the Amazon of China. Basically, that's the biggest e-commerce there. And they also did some PWA, which has a huge, basically double the conversion, which is very important. Okay, and Twitter has its own PWAs, and there's pin interest as well, and there's Starbucks and Tinder. So these are all PWAs. Okay, so I'm gonna do a quick demonstration to show you how can you see how PWA an app is. As we said before, it's not say a yes or no binary choice. It's more like a percentage wise, a spectrum. And so this is the essentially the PWA app of Starbucks. Okay, and if you go to the develop tools of your software, maybe I'll do it this way, and you go to the last tab, which is called Audit. I'll make it a bit bigger. Oh, the auditor is gone now. Okay, so it will be able to check the website you're looking at against lots of things. So you can check performance, check progress of web apps. So that's what we're going to do now. But the equals is to check if it follows best practice and accessibility, which we didn't cover. For example, for people with say an like a vision impairment, can't really see, or search engine optimization. You can test all these things. Uh, but today we're going to just test, say, how good the website is in terms of being a progressive web apps. And then that's it. You just need to run audits. That's all it does. And then it's what happens. And they try to say display the app on a phone and see how it works. And then to take a little bit of time. Okay, so that's give you the indication. So it tells you that this red thing, that means something it didn't quite match it. So it says it loads too slowly and not interactive within 10 seconds. This is on the, I think this is probably simulating some quite slow mobile connections. But also there's other things we mentioned before, make it installable. Okay, that's all ticked. All these green means they're all fine. And then these things using HTTPS and some other things, these all match the requirements. So in a sense, this is quite PWA, right? So it's, and we're going to look at another example, which is the university website. Okay, so, and we can just do the same thing again. I can clear this out, and we run the audits again. So it was just to test if the website would work as a PWA. Okay, and take a little bit of time. So basically it tests a few different conditions. Okay, so you can see there's lots of things which is missing here. So the first is saying it's loading too slow, and it cannot respond when it's offline. So basically, it's not saving anything content locally, and there's many other more which didn't meet the requirement. Yeah. So obviously, the second one is much less PWA than compared to the first one. Okay. Oops, I don't need this one again. And yeah, so that's some examples. Okay, and in the lecture, I'm going to have two lectures on this. We're going to use a simple example to see how do you turn a web app or website into a PWA. So PWA is not something you have to build completely new. You can take an app and turn it into PWA or make it more PWA-like, adding certain things to it. Okay, and so what we're going to do is we're going to look at the web page which listed the game submitted to a competition called the GS13K games. Okay, so that's the website. Hopefully, yeah. So what it does is this competition asks you to write games using JavaScript only, and the file size can't be larger than 13 kilobytes. So it has to be quite small. And the website itself is just listing all the entries people putting inside. Or not this one. Okay. And the website itself, it's a bit later. And the website itself is just to list all the games people submitted to this competition. And so, in a sense, and what the actual content is less important. The more important part is how do you make the website a PWA. Okay. And so this is what the website would look like. And it's very simple. You had a title, and these are the entries. And the people submitted the games people submitted to the competition, and there's a bit more information on this side. So about the author, the Twitter handle of the author, if they have website or GitHub or some other information. And then you have a picture for each of these games. So we're going to use this as an example to see how we can make this and website PWA-like. Yeah. And so this link, the URL is a bit small, it's hosted on GitHub, and it's already optimized and for PWA. So we could just run the same thing here, the Lighthouse, Audit, and you run. Okay, and you can see, and this is probably even more PWA than the, say, the Starbucks examples. It matches all the criteria except this one. Actually, something a bit new. So you get 2 badges instead of just 1. And if it's terrible, you don't get any badges there. Okay. Yeah. And so this example, the original example, actually is not implemented in Vue.js, and it's using the kind of a little bit clunky using the basically do a search and replace and in the template. And then we're going to try to rewrite that into Vue.js as well as we go through. Okay, and so before we actually look at the code, we're going to explain how the PWA works. So we already explained server-side rendering and client-side rendering before. Anyone remembers what's the difference between the two? Or what makes a server-side rendering? No. And a server always sends the information in both cases. The difference is what information it sends. So in the server-side rendering, it sends the actual HTML page to the client, the browser. So you receive the HTML, CSS, and anything else needed to show a page. Whereas the client-side rendering, and you receive the data from the server, so you receive a JSON file, but also the actual HTML page will be constructed locally. So say you update your page or create a list of items or divs on your page to show say, the course, and this is rendering. And that's the process of the rendering, which is done locally. That's the main difference. Okay. And so in terms of speed, and speed in the sense how long it takes when between the user typing the URL and see a page on the phone, that kind of speed. And the server-side rendering is faster for the first view. So if you just never visited the site before and you want to see the part of the home page, server-side rendering will be faster because it can just send you the user the rendered HTML page, and the user just needs to display it, so that's faster. And client-side rendering is faster for anything except for the first page visit. And for example, if you need to navigating between different pages, it's much faster to load a new page it's much faster to just update the page locally with the new data. For example, the title of the page changed, so you just change that, the title of the page. Then load an entire new HTML file from the server, right? Okay, and so the PW itself, and it tried to miss these two models. And so for the first initial load, it tried to use the server-side rendering, so try to load HTML and CSS. And then for everything else after, it tried to do client-side rendering, so that's because that's faster to achieve the best performance. Okay, and so you just need to remember a term called app shell. So that's like the name, what you call this mixed server-side rendering and client-side rendering. Okay, so here's some abstract description of how the app shell works. And so what it does is, for the first time, the user visiting a website, it tries to load a minimum user interface as soon as possible, so the user don't have to wait too long to see something. And then from the second time on, it will try to load things from the cache. So basically, all the HTML, CSS, and pictures will be stored locally in the cache. And then in that way, they'll be even faster than loading from the server because it don't have to go through a network. Usually, it's much slower than say load from your hard drive or even memory. Yeah. So the cache actually say the browser also use them as well. Say for example, Google Chrome, it will try to cache the website you visit. So when you visit next time, it does not have load everything from the beginning, from the server. But this way, you have much more control of what to be cached and what to save and not save. Okay. Going quite fast. Okay. So these are the files, and in the example, and so that's the website structure. So this is the code repository and on GitHub, but the actual repository looks like this. So the folder structure, and you have an app.js as the main code, and then you have the data directory which saves all the data, and you have games.js. You might be wondering why .js file is in the data directory. So actually that's just an array of all the game names, that's all, even it's a JS file. It might be easier if I just show you in the editor. Maybe do this one. Yeah. Okay, so that's the same file structure. So you can see under data, you have the image directory, which are all the pictures, each picture for each of the games you need to display on the page, but also the games file. So essentially, it just lists all the information about each of the games. even this is essentially that's also data, but it just says for each game you have the slug, which is actually the name, image name for the game, and name also Twitter, website, GitHub. So those are the things which you see on the page for each game. Okay, and so the images are these pictures on the left hand side, and in the games.js are these information for each game, right? So that's the data directory. We get uh, where's the slides? Yeah. Okay, and then maybe it's easier to explain that just in here. Then some other things. For example, you have a fonts directory which has some special fonts that you needed for the web page. Again, these things can be cached and preloaded to speed up. And then some pictures. So these are actually the pictures used for the web page. You can see that's the background and that's the logo, these things. Okay, and then you have the index page, which is the in HTML for this page. So you need some HTML to render this page. That's what that is for. And then you have this file called app.js. We're going to have a look a little bit later on. So this is the initial ways how it creates the index page. And finally, there's this file called sw.js. That stands for Serviceworker.js. So it's just called sw.js. And its main job is just to say decide what files to cache. And again, we're going to go through that a little bit later. And 3, no, 2. Okay. So that roughly explains all the files in here. And the only thing actually we didn't have was this web manifesto file, which we're going to come back to a little bit later. These are like the configuration files for PWA. Okay, so we're going to have a look at the HTML file first. Maybe make it slightly smaller. Okay, so we're going to go through. So that's the entire file, which is used to create, not this one, create this page. Okay, so we're going to look at the part by part. Okay, and so in the head section, you have set the meta, set the title, and link to the CSS file to formatting your pages. That's all fairly standard. And then, okay, so this line, and it loads the data. And I will explain, so the games.js file saves the list of the information about all the games. So you need to load it so you can use that in the other JavaScript file. And it has a deferred tag that basically tells the browser you don't have to finish loading this file when you display it before you can display the page. Okay, that's one way to speed up the display. And then similarly, the other one is the app.js, which is this file. So that's the one actually used to create the page. And it also asks you to defer, just to say, and without finish loading this, just display the page. Okay. Yeah, maybe not the easiest to look at here. Let me see if the in the codes. Okay, so if we look at actual code, we just had a look at this part. And then in the actual body part, which is the main code, you have the header with the ER, and you have a paragraph. Inside, you have a picture, which is the logo. and it says the logo itself is also a link. So if you click that, it goes to this URL. So basically, that's basically this thing here. That's your logo. That's what that does. Okay, and then in the main part of the page, and you have a heading, say that's just the title of the page. There is a paragraph, okay, and then there's a button just called Request Dummy Notifications. So this is here, your title, that's your paragraph with a few links, and there's this button which give you dummy notifications. You have to allow for it to. Ooh. Ah, doesn't work. Okay, let's have a look at that when we get to there. Okay, so the actual important part is here. So you have a section is ID called content, and currently nothing is there. So this is where actually the list of all the games will be inserted using the JavaScript code, more specifically in this app.js code file. We're gonna see a little bit later. So basically what we want to do is we want to insert all these and each of these games into the page later. And currently, if you look at only the HTML file itself, and it's empty, there's nothing here. And finally, you have a footer, so that's something at the very bottom of the page. And again, that's quite straightforward. If you scroll down all the way, you can see that's the tiny little thing at the very end. So this black bar. Okay. So we're gonna have a look first and how do they actually create this list of games on the page. Okay, so as I mentioned, and this is done using app.js. So the code in there, that's the OD code. Okay. Maybe I give you like maybe a minute or two. You can have a look to see if we can, because it didn't use anything else. It's only using JavaScript and HTML. Try to create a template. So the general idea is load data from the games, if you remember, and the array in the games.js file, and try to create kind of using a template to create like a block for each of the game. Does it kind of make sense now how they try to do it? Okay, and so first, they defined this something called a variable called template. So what they call template essentially is just one string, one text string. That's all it is. But what is inside the string is actually an HTML code. So basically up here to here is actually HTML code. You can see, okay, yeah, there's article tag, and then there's image tag, and the source of attributes, etc., etc. Right? And so this is basically all the HTML code for each of the games. And for each of the games, it will replace certain things. For example, it will replace here with a number, and then for example it will change the actual file name to replace, for example, here the slug.jpg, right? That's what they do. So that's what I do here in this for loop. So it says variable I equal to 0, I less than games.length I plus plus. So this is a loop, and if you remember, anyone remember what the games is? Yeah, so that's the array we seen before. Let me see if I still have it. So basically, that's in this file, and defines an array that called games. and that get loaded, so you can use this array in other JavaScript file. Okay, and then for each game array item, what it does is says entry, that's a new variable, which essentially is the template. Okay, so that's this template here, and it says replace. So that's just basically a JavaScript string method to replace certain part of the string, and it says I'm gonna replace this part, which give you this one. I'm gonna replace that with I plus 1. So we'll start with 1, and for the second one will be 2 and 3 and 4, etc., etc. Then you're gonna say I'm gonna replace this slug g, which actually is this. I'm gonna replace that with game I dot slug. Okay, so if we look at the code again, so for game 0, the slug will be this. So what it does, it will, instead of having source data equal to data slash image and slash slug.jpg, it will replace the slug to lost in cyberspace. So this will be replaced as data slash image slash lost in space.jpg. So they get actually the proper picture for the game. And it's the same, then you replace the name with GameI.name, so the actual name of that. And similarly, this is the name here, it will also get replaced as well. You do the same for the author Twitter website and the, yeah, and also the link as well. Okay, and finally it says content plus equal to entry. So that means the content is start with empty, and you do all these replacement here, and you created this entry which has all these, say, the image name and position replaced with numbers and actual names, and you add that into the content string. Does that make sense? Yeah. And you, every time you repeat this whole process, you create a new entry for a next game, and you add that to the entire, to the content variable again. So after you go through the entire games array, and you would have one entry for each of these games, and all the code will be in content. Okay, and eventually, that's the last line, and says, and document get element by ID content, and if you remember, the content is in the section, is actually the section. So if you look at, so this is the section which has the ID called content, and what it does is says I'm gonna replace the in the HTML with content. So you're gonna just basically here, that's this one here, which contains a list of all the games, right? So that's why when you display, you have all this list of games on your page, and one for each game. Does that make sense? Yeah. So this is how it does. So not using any libraries or something fancy, just by creating a string and replace that part of the string every time. Okay, and so obviously this is also something you can do with Vue, right? So Vue is quite good at doing this. For example, and this is the loop, and then you can use v-for. For anything that needs to be replaced, you can define as a variable in the Vue, and for each of the game, and just replace that variable. Okay, and okay, and so this is to achieve something very similar, but using Vue. And so, really, so instead of using a loop in the JavaScript code, you just say v-for, and let's say for in games, because this is already defined games, do you know, for each individual items, and you can say the image source equal to this plus game.slug, all right, and then .jpg, and then the alternative will be game.name. So that's again the property, and here just display the game.name, so that's what done before. And same here, say the author just will be game.author, etc., etc. And the Twitter name, the reference, and here just say game.twitter. Yeah, does it make sense? So basically, you don't need, instead of doing everything here as a replacement, you define each of these, for example, name, as just use and just game dot directly, rather than have to go like this. Okay, so certainly less line of code. And in the JavaScript code, and you really just need this, you connect your view app to the content element, and the word does exactly the same thing. Yeah. Does that make sense? You should be familiar with it by now. And this is probably easier to see and debug. First, it's less line of code, but also this is all properly HTML code is easier to see. Whereas here, this is actually meant to be HTML code, but the editor would not be able to recognize it because it's all in a text string, making it a bit harder to say debug. If there's anything wrong, for example, you're missing a closing tag, the editor itself will not be able to pick that up because it doesn't understand this is like embedded HTML code inside the text string. Okay, and now actually gets to the PWA part. And so now the first part is to register something called a service worker. I'm going to explain what that is. So we will have this line of code in the, let me see, this should be in the app.js. Okay, and so in the app.js, we have covered these things so far. Right, so that's how do you generate that list of games. Now we move on to this part. And so the first one is to register a service worker. That's before you can use it. And then, so this line is just to check if your browser supports service worker. So if you're still using, say, Internet Explorer, older version of the Internet Explorer, so it might not support service worker, but most modern ones support. And so here, the navigator really just means the browser. And it says if service worker in navigator. So if it supports, it will return something. And then you can just return something, say not empty. Then you just register. You say navigator, it's the same, dot service worker dot register. And this is where the service worker code is. So in this case, it's inside this sw.js file. So if you look at the code, that's this file here. Okay, I'm going to explain in a second why do we need to register. But this just says, okay, all these code here are for the service worker. We're going to explain what those are a little bit later. Okay, and so this is the next part is not directly related to service worker. It's just about notification, allow user to send notification. So it's that's for this one here, and that's maybe a bit bigger. As for this thing here, and so if you remember when we first clicked it, it asked pop-up windows to say it wants to send you a notification to allow or disallow. That's what for the line the code is for. Okay, so it says the button will refer to the document element with the ID called notification. So that is this one here. So that's your button here, which is notification button. And it says add event listener, click function E. So this one again can be done easily with Vue, which will be less, right? You need a less line of code. It says notification dot request permission and then the function result, and say if results equal to granted, that means if you click yes, and you run this function called the random notification, which is the next one. Okay, so these are all about the notification part. So, and basically, okay, again, maybe let you have a quick look of this. Again, this is nothing new. This is standard JavaScript. Yeah, does that make sense? Okay, and so essentially, this is the line which actually creating the notification. So to create a notification, you say new notification with the title of the notification and some options. And all these lines is to generate the random titles and random options for that notification. That's all it does. And so the first line is to first pick a random item. And then what it does is just pick a random index number. So you pick from out of the array. So mass.random give you a number between 0 and 1, and it times games.length, so that give you a number between 0 and the length of the array, say it's 10, 20, or 30. And then you choose mass.floor, so that makes it an integer, which is just less than the number, random number generated here. Because this one is probably not an integer, it has something after decimal points. Okay, and then basically, then this is probably, it's better called the random index. So that gives you the index of the array that you're going to display the game information in the notification. So you say the title of my notification will be that element and dot game. Sorry, dot name. So that gives you, if you look at sorry, the games.js. So basically, that will be whatever the information is here in your code. Lost a space or vernissage or something. Basically, that's the title. And then created by, you will pick up the author information from the JSON object, and you have a picture as well. Wow. And here, this is the option object. You need to include it in the notification creation. So you need the notification body, which is this one, and then notification image, and which basically, and just pick an image from the. Okay, and finally, anyone remembers what does this do? No. Yeah, I think this is probably covered in the second year. Basically, it says something called set timeout. That means you wait for a certain amount of time and then run it. I think this is repeated as well. So it says wait for 30,000 milliseconds. That means 30 seconds. So after 30 seconds, you run random notification, which is this one. So basically, it will display a notification. After 30 seconds, display another one, each time with a randomly picked game. Yeah, it would be quite annoying. You don't really want to do that. This is just to demonstrate to say you can do notifications. So let's try again, see if we can get this one to work. So obviously it doesn't work. I don't know. Somehow the notification is blocked. It's not showing anything, and you can see the light. Okay, at least you can see here. After a while, it tries to get a picture every time. Somehow the notification is not displaying on the page. Whoops, I probably need that. Okay, now let's actually get back to the service worker part, which is probably the more interesting, slightly more difficult part. Uh, so the service worker work as a virtual proxy between the browser and the network. Does proxy make sense to you? Anyone knows what proxy is? No? Okay. Uh, so proxy, I guess in the computer network sense, is something in between the client and the network. And so without the proxy, what happens is every time you need to say visit a website or download something, the request go from the application to the network directly. So the proxy is just something in between. So if you have a proxy, all the requests will go through the proxy first before it goes to the actual network. And similarly, for any response come back in, it will go through the proxy first as well, and then get to your application. Does that make sense? And so besides Service Worker, a very common proxy you might use is VPN. So it's essentially a server there. So any request you send out to, for example, I want to visit the google.com, some come from a browser, go to the proxy, and then go to the Google server. So the reason is using that is because from the Google server point of view, the request is coming from the proxy server, not from your browser. So for example, you might be in UK, and if you contact Google server directly, it will know, okay, this request comes from UK. But if you go through a proxy server, for example, is in the US, and then the Google server would sync the request come from US. Does that make sense? And you can do other things as well. For example, on the proxy server, you can do certain things to your request. For example, check for any threats or virus or anything, and before it allowed pass on to your applications. Yeah. Okay. But in this case, the service worker is using this proxy and to decide whether it goes to the internet to get more new files or just go to local cache. So as we said before, when the application first run, or when you first visit the website, you have to download everything. The service worker will download everything and save that in the cache. So next time when you say, I want to load a new page, and the service worker will go to the cache to check first, because it will get the request you send from the browser, and to see if the already exists in the cache, and if it is, it doesn't go to network anymore, just get data from the cache to the application. And only if it checks it doesn't exist from the cache, and it will go to the network, actually get the files you need and send back. Yeah, so that's why we need service worker in the middle. Does that make sense? Yeah. Okay. There's some other things. Yeah.
Without a service worker, does that mean that web page can't be cached? You don't have a service worker.
No. The service worker does not say works independently from the caching of your own browser. So you can imagine the service worker maybe one with a proxy, and inside maybe here is another second, say a proxy server which is created by the Chrome, which manages its own caching, and maybe other things along the way as well. Yeah. So this one only look after the cache it creates, and then say the Chrome can do other things, yeah, along the way, which will be independent, will not interfere each other. Okay, so some technical details. So the service worker runs on a separate thread. Does that make any? What is what does a thread make any sense to you? What would a thread be? File. Okay. So uh, you maybe came across in, for example, in Java. So most program is run in the sense of single thread. So it only means it can only do one thing at a time. For example, it's displaying, I don't know, do some calculation. Then that thread will be occupied and to calculate, or just say count numbers from 1 to 1 billion. And in a single thread application, that when that thread is working, and nothing else can happen because everything else have to wait till this counting finish. And then yeah, we discussed that a little bit before. So that's not very useful in terms of, because when you do something take a little bit long time, the whole software or app looks kind of freezed because it can't respond to anything and will not doesn't want to change. Okay. And by having multiple threads, that means multiple work can be done at the same time. So you can have one thread doing computation, one thread doing counting numbers, a third thread getting the input from the user and update page, a fourth thread, say, retrieve data from server, etc. Right? Okay, and so by design, and the service worker won't run a separate thread from the main thread, which handles the display of the web page. So the user can still interact with the page, it will still respond, it will not affect that performance. Okay, and also importantly, it don't have access to the DOM. So you cannot refer to any elements on your page in the service worker itself. It doesn't work. You can't say change, updated the page or the title of the page or anything. Okay, and so as a result of these, first it's non-blocking because it's a separate thread from the main thread of JavaScript, and also the other one is anytime you use a service worker to do something, you have to use a promise based. In a sense, it's async, so you can't expect the result straight away because the processing, whatever job the service worker has to do, will take a while before you can get the results back. So again, just as you say, try to retrieve some data from a Node.js server, so you have to use a promise to say, okay, gonna so the node so the code or JavaScript virtual machine needs to know, okay, I'm gonna wait until I get the response, and then I will do something, which is a promise. Yeah. Okay. So these are some of the things that you can do with Service Worker. You can use that to handle notifications and perform heavy calculation on a separate thread. Something might take more than a few seconds. Okay, and you can actually take over network requests. So because every network request has to go through it, if you remember here, for example, people can make a malicious network, proxy server or service worker, which say direct all your requests to something else. For example, and you want to access your bank, for example, HSBC, and you think you are sending all the requests to the HSBC server, but the service worker can direct all your requests to some malicious website which pretends to be the HSBC website, and you would have no idea knowing that because you would, unless say there's something obvious on the website itself, you can see, for example, visually the page looks different. Otherwise, all the data sent actually to the HTTP server can be redirected to something else. Does that make sense? Yeah. So that means can be really powerful, and as a result, a service worker can only be executed in secure content. What that means is it has to be done using HTTPS protocol. That means that the communication is encrypted, and also the server has to be identified or proved. You can't anyone, not any website can say I am HSBC, and only the website has the certificate that can prove that it's HSBC and can have the URL. Okay. And does anyone remembers or knows HTTPS? What that is? Yeah. So you probably can guess. So first you remember. So the HTTP is the protocol you to send to send your request and get back, say, a web page. That's how you. So every web page is done using HTTPS actually, and it's just saying here in Chrome, it's hide them, and then so the HTTPS is like the security version of this. So in HTTP, all the communication is sent in plain text format. So if you remember, I send a GET request to my Node.js server, say, uh, for example, like it's not here, but it's, let's say I send to localhost something, and then in the message itself, I have some payload, some JSON object I send to my server. So in the normal HTTP, all this information anybody can see, so long as they can get that HTTP request message, which actually is the case. And because, okay, okay, we have some time, so it's a little bit digression. So, but in the sense, so when you send a request from your, say, laptop to Google search website, and doesn't go to the Google server directly. It goes through many other things. For example, it first goes to the wireless router in this room, and then maybe goes to the university server somewhere, and through many other routers before it finally gets to the Google server. And any kind of nodes on this path, say the the Wi-Fi router, university server, or any other router on the road, can see your entire request. If it's not encrypted, basically you can see the type of message and payload, etc. Okay, so that's very unsafe. Whereas here, if you use HTTPS, they can still see the message, but it's encrypted. They will not be able to know what that is. Basically, just a random characters. Yeah. I think, for example, now in Chrome browser, it is required to use HTTPS to access anything. If it's not, it actually will give you a warning, say recommend not to visit that. Okay, and so yeah, so the way that service works, the service worker works, is first, and it will try to load everything from its cache first. Obviously, when you first visit the website, nothing is downloaded yet. You have downloaded everything from the server, and after that, then it will try to load the files from the local cache whenever possible. Okay, and yeah. Also, this is in a sense progressive in the sense. So if your website the browser does not support Service Worker, that means it's very old. That's a new API it doesn't support, and that just sort of basically means every time you request something, it will go to the server. It will still work. It's just maybe a bit slower than say it supports Service Worker. So that means what the progressive means. Okay. Yeah. So we already seen this line code before. So that's say we said if the browser window supports Service Worker, then Service Worker in Navigator will return something, not empty, and then that will be true. And then you can run this line of code. You say navigator.serviceworker.register. That's all my code I want to run in the Service Worker. Okay. Okay, so we're going to cover a few more, and we'll not be able to cover everything about service work today. That will be done next week. So we're going to cover the first part about caching the files. Okay. So the first step in running a service worker is installation, which is essentially the registration, and you can decide to do something when the service worker is registered or installed. So you can say add event listener install, and this is installing. This event will happen when the service worker is successfully installed, and you can do something. For example, you can say console log service worker installed, for example. And this particular here, the self means the browser window. Let me see if I can have this one here. No. Oh, maybe it's in the App Store. Okay, it's actually here inside the and service worker JavaScript file or the SW. Okay, and then another big part of the code is actually just to create the list of files that you want to save locally in the cache. That's all it is. Okay, and you have to give the cache a name, so you can refer to that later, and that's the cache. And this v1 is also important. That tells the service worker when to update the cache. So when it becomes v2, and the files will be updated. Okay, and then this is a list of the files that's needed, and it says app share files. That's just a variable name. That's an array of all these files that can be saved locally, and you don't need to. That means next time you don't need to retrieve from the server. So the people creating the website will know what files is needed or necessary and can be saved locally. So you have the index, and these are the main files, the CSS and JavaScript, and you can locally save all the font files as well. So next time you don't need to load from the server, and that's your favicon, so basically the icon for the website, and some pictures and different size of the icons. Yeah. So that's things useful to display the page, but it hasn't saved any information about the actual the games yet, right? The pictures and the information is not here yet. Okay, so it do it in a slightly more compact way, and so essentially this is just an array of list of the file names that you need to save, and here it's just adding more to that list. So what it does, and it adds all the pictures in the data directory to this array list. And so if we have a look again, so here we have this image directory, and all these are all the pictures for different games, and we want to save all of them and add all of them into the service worker list as well. And instead of say write them one by one and similar to this, instead it writes some code like this. So it's create a new array called games image. So it starts with empty, and each element will be a string which pointing to the image file that needs to be saved. And it says for variable I equal to 0 less than games.length. So basically that is going through the this file, going through this one, array, games array. And this one, we push data slash image slash game I dot slug. If you remember, that is the actual picture image file name without an extension. Okay, and so you do this. So by the end, when you complete this game's image array, would have all the pictures inside this directory. Does that make sense? Not as actual pictures, but this is the file names of everything inside here. Yeah, hopefully it makes sense. And finally, you add this list of files to the app shell files which is basically which is just this list. So basically there'll be a longer list with more files at the bottom, which are these, say, /data/images/something something.jpg. Okay, so now, so after you register and install the service worker, you create a list of the files you want to cache, and then this is actually caching the files. Okay. So uh, so does not install the code. Wait until it's executed. To the promise. Okay, and this is actually not caching and all the content yet. And so we're seeing these lines of code before. And what it says, when the install events happened, it says, and service worker is being installed. And here it says cache dot open cache name. And if you remember, the cache name is defined here. So that's the name that will show up in your local cache, not local storage. And because this one is a promise, and this is actually where you're starting to adding all the, downloading and caching all the files. So this is just a console log, and it displays a message. That means we are currently downloading and caching all the files. So these are the files you listed in the list here, plus all the pictures. Okay, so this is the actual thing. So it will say cache dot add all content to cache. So the content to cache is this variable, which you can basically that's the combination of the FShell files and say game images, these two arrays. So on this line, this part, it's actually adding all the files to the cache. Yeah. Okay, and then we can actually have a look at how that works. And so this is the website, and so your local cache is actually somewhere similar to where you find local storages. So if you go to applications, yeah, and you have your local storage, etc., those things up here. For example, there's nothing there, and you will have a cache, and here you have the things there. So you can see. So there is a JS13K PWAB1. So that's the name you given in the code. That's in the SW here. That's your name given here, and that's why you when say it's here. So cache.open cache name, right? So then it will create a cache in your browser, which is called that name, and starting to adding things. But at the very beginning, none of these will exist yet. And then when you run it, and it will start adding this. So for example, I could clear the cache, so I can just delete this, and then can reload the page again. So you can imagine when I reload the page, and it will run the service worker code, which will say create a list of the files that need to be cached, and then add them to the actual local cache, right? So that's what would happen. So if I refresh this page now, and it will getting everything, I try to fill the cache, fill the local storage, the cache storage with all the files. Yeah, so you can see these things are populated. And actually, if I go to console now, clear those, and I refresh the page, yeah, and you can see it does not very clear. But actually, when I refresh the page again, it doesn't go to the website to download most of the things. Everything is already in the cache, and it will automatically download from there. Yeah. Okay, that's all we have for today. And we haven't quite finished yet. We're gonna continue with the service worker next week. And so these are the readings, and part of the tutorial. There are 3 links. If you and click it, go to onto the page, and which is very similar to what we covered in the lecture. Yeah. Okay. Discuss code with you.